All right, lesson 11-3A, imaginary and complex numbers. So we're finally getting to that point where we're going to find out what happens when we get no real solution. And we're going to start looking at the imaginary solutions. Our question for today is, what complex number would you multiply 5 minus I by to create a real number? Show your work. All right, so let's get started. If we've got the square root of -1, we've said that that doesn't exist. It's not a real number. We call this the imaginary unit. And from here on out, anytime we see the square root of -1, we can replace that with I. I stands for the square root of -1, a number that just doesn't exist on the number line. All right, complex numbers. Complex numbers are in the form of A plus B, I, where A and B are real numbers and I is the imaginary unit. Basically, what we're looking at here is A and B can be real numbers. Let's say that A is 3 and B is 4. So a complex number might be 3 plus 4i, meaning that we've got a section of it that's real, like the 3 by itself over here would be real, but then 4i would not be real, meaning that it's not on the number line. So a complex number has a real part of it and an imaginary part to it. All right, so what we're going to do today is start by simplifying our imaginary numbers. Where's green? There it is. Example 1. So I've got the square root of -16. And before we would just stop and said, oh, there's no real number to this, but we know that there's an imaginary number to this. And so what we're going to do is we're going to split it up into a real part and an imaginary part. So I can, based on Unit 8 that we did a long time ago, I can take this and say root 16 times root 1, or root -1. So root 16 times root -1 is the square root of negative root 16. Now we have a portion that can be reduced. Root 16 we all know is 4. And now we know that the square root of -1 is up here. It's I. So we're going to change this into 4 times I, or just 4i. All right, so that's all there is for that part. Example 2. Let's take the square root of, let's do, 8i. No, -8. Screwed that one up. All right, same deal. We're going to split it up into the real portion of square root of 8 and the imaginary portion of negative 1. So square root of 8, we know we can reduce this. This is 2 times 4. This is 2 times 2. So I got a pair of 2's and a 2 left over. So I can take the 2 out. And then inside the square root, I've still got a 2. So that's what the square root of 8 reduces to. And then the square root of negative 1 is I. So the square root of negative 8 simplifies into 2i times root 2. All right, next we're going to look at some patterns here. First of all, we know that I to the first power is just going to be I. Because anything to the first power, you don't really need the first power there. It's always there if you can't even see it. So I to the first is going to be I. But I to the second is going to be interesting. If I take I to the second, I to the second is the same thing as the square root of negative 1 squared. Because I is the square root of negative 1, right? Now, what did we say happens when we square a square root? Well, we've said that if you square a square root, they're opposite operations. So squaring cancels out the square, and we get negative 1. And that's real. That's not imaginary. So if we take the imaginary unit and square it, it becomes the real number of negative 1. Now let's look at I to the third power. I to the third power can be rewritten as I squared times I, or I to the first. And we already said that I squared was negative 1, and I to the first is I. So I to the third can be reduced to negative 1 I, or just negative I. The I squared became negative 1, and the I to the first just stayed I. So I to the third is always negative I. All right, let's do one more step. Let's do I to the fourth. I learned back in Unit 8 that I can change this into I squared times I squared. And what did we just say that I squared was? We said that I squared was negative 1. So instead of I squared, I can make that negative 1. And this is I squared, so times negative 1. And negative 1 times negative 1 is positive 1. So I to the fourth is actually positive 1. All right, so I to the first, I. I to the second, negative 1. I to the third, negative I. I to the fourth, 1. I know this is dragging this out, but let's do I to the fifth real quick. I to the fifth is I to the fourth times I. But we already said that I to the fourth was 1. So this is just 1 times I, which is I. So I to the first was I, and I to the fifth is I. Okay, now let's look at I to the sixth. Well, I to the sixth is I to the fourth times I to the second. And we said I to the fourth was 1. So this is 1. And I to the second was negative 1. If I take 1 times negative 1, I get negative 1. So I to the 6 is negative 1. See the pattern that's starting here? I to the 7th. I to the 7th is I to the 4th times I to the 3rd. I to the 4th, we said was 1. I to the 3rd is negative I. 1 times negative I is just negative I. So I to the third and I to the seventh are both negative I. And to finish this off, I to the eighth. I to the eighth is just I to the fourth times I to the fourth. And I to the fourth is 1. So this is 1 times 1, which is 1. And this pattern of I, negative 1, negative I, 1, is always going to continue. Every fourth power, you're going to get the same pattern repeated over and over and over again. So let's look at what we've got here. It's all based on a pattern of 4. So when you have your power has a remainder of 1, so when your remainder is 1, when dividing by 4, you're going to get I as an answer. This one has a remainder of 2. So when 2 and 6 are divided by 4, there's a remainder of 2. Remainder of 2. And we see anytime we divide these two numbers by 4, we get a remainder of 2, which means anytime you have a remainder of 2, you're going to get negative 1 as an answer. When we divide 3 or we divide 7 by 4, we get a remainder of 3. And now we know that anytime we get a remainder of 3, we've got negative I as an answer. And then if there's no remainder, so 4 divided by 4 doesn't have a remainder, 8 divided by 4 doesn't have a remainder. So no remainder. We're going to find out that it's always going to give us an answer of 1 because this pattern is going to continue forever. So what if we got on example 3, let's simplify I to the 42nd power. Well, what we would do is we take 42 and divide it by 4. 42 divided by 4 is 10 with a remainder of 2. So anything with a remainder of 2 has negative 1. So I to the 42nd power would be negative 1. Let's look at I to the 80th power. Well, I'm going to take the power of 80 divided by 4, and 4 goes in there exactly 20 times with no remainder. So when you have no remainder, your answer is going to be 1. And so on and so forth. So whatever power you get divided by 4, if you got a remainder of 1, your answer is I. Remainder of 2, answer is negative 1. Remainder of 3, negative I. And no remainder means that your answer is going to be 1 for that one. So your final answers should never have I to some kind of power. If you got I to the second in your answer, you need to change that to negative 1. If you got I to the 7th in your answer, you need to change that to negative I. There should never be an I to a power in any of your answers. All right, a couple more things to cover. Adding and subtracting complex numbers. All right, example 4. 4. So on example 4, we've got 7 minus 2i plus negative 3 plus I. All right, so what we have here is we've got complex numbers with real portions and imaginary portions. The real portions are like terms. So those two are like terms. I'm just going to do 7 minus 3, which is 4. Then they have imaginary portions to them. Negative 2i and positive I. Those are like terms because this is 1i. So I've got negative 2i plus 1i gives me negative 1i, or just minus I. Example 5. Let's take 1 plus 5i minus 3 minus 2i. Okay, in this one we have a subtraction sign in between, so we're going to need to distribute it to the second equation, or the second complex number here. So this is negative 1 times 3, which is negative 3. This is negative 1 times negative 2i, which would be positive 2i. And now we'll just combine our like terms. 1 and negative 3 are like terms. That gives me negative 2. 5i and 2i are like terms. 5i plus 2i is 7i. All right, almost there. Example 6. We've got negative 3 plus 9i minus 3 times the quantity negative 3, negative 3 minus 3i. Oh! Got to walk around and wave on the lights again. There they go. Hate when that happens. Drive me crazy. Okay, lights back on? Yeah. Okay. Breathe. Okay, everything's going to be fine. It's all going to be fine. So, over here, we've got negative 3 plus 9i. This section doesn't change. Over here, I'm going to distribute negative 3 times negative 3 would be positive 9. And negative 3 times negative 3i would be positive 9i. And so we're going to combine our like terms. We've got 3 and 9, which would give us 6. And we've got 9i and 9i, which would give us 18i. I didn't do it, but it is possible to get rid of your imaginary numbers. Let's say that this one would have been negative 9i. If you take 9i and if this were negative 9i, your i's would have canceled out and you would have had no imaginary units, and your answer would have just been 6. So if you got negative 3 plus 9i plus 9 minus 9i, these two would have canceled each other out and you would have just gotten 6. So it is possible to get rid of your imaginary components by adding or subtracting. All right, we are almost done, but not really. We have to multiply complex numbers together. All right. Let's see if I can cut out some examples so we don't have to do so many of them. Multiply complex numbers. All right, example 7. Are we already on example 7, really? Yep, example 7. All right, so example 7. We're going to multiply 7i times 3i. We're just going to treat I as if it were a variable. So 7 times 3 would be 21. And I times I would be I squared. All right, but remember what we said on that last page is if you have I, it cannot end up to a power. And we found out last time that anything with a remainder of 2 was actually -1. So I get 21 times -1 because I squared is -1. I get -21. All right. Let's just do 3 more examples. Example 8. Got an email. Example 8. We've got 2 plus 3i times the quantity 4 plus 5i. And we are going to just go back and use our Punnett squares for these. So I'm going to make my Punnett square. I'm going to do 2 plus 3i over here, and then 4 plus 5i here. 4 times 2, 8. 3i times 4 is 12i, and 2 times 5i is 10i. Now the interesting one, 5 times 3 is 15, and I times I is I squared. But remember, I squared is actually -15. Because remember, I squared is -1. So this is -1 times 15, -15 right there. So our like terms are 8 minus 15. So that's -7, I believe. And then 12i and 10i are like terms, and that makes 22i. So anytime you have that I squared is -1. So this is 15 times -1, -15. So 8 and the 15 diagonally here are like terms, and then the 12i and the 10i were like terms there. Let's try one more. At any time, if you want to try to practice these on your own, just hit pause after I've written down the problem, and then see if you can do it yourself. Example 9. We're going to do 6 plus 5i and times 6 minus 5i. All right, if you notice this is the difference of 2 squares that we did when we were factoring or when we were multiplying. We noticed that these ones turned into binomials. So this is going to be interesting. And this goes back to that question that we asked at the beginning of the lesson. So if you're wondering how to answer that, this is the problem that helps you answer that question. So I've got 6 plus 5i, and then I've got 6 minus 5i. 6 times 6, 36. 6 times 5i is positive 30i. 6 times negative 5i is negative 30i. And then negative 5i times 5i is negative 25i squared. But we know that I squared is negative 1. So this one is actually negative 25 times negative 1, which is positive 25. And then 30i minus 30i, those two cancel each other out. So what am I left with? I'm left with 36 plus 25. And we get a real number from this, which would be like, what, 61? Yeah, 61. So when you have the difference of two squares, it's possible to end up with a real number of 61. All right, very last one. Why did I make 10 examples? I apologize. We shouldn't have done this many. 3 minus I squared. All right, we know that 3 minus I squared can be turned into 3 minus I times 3 minus I. And then you can just do the Punnett square from there. You cannot just square the 3 and square the negative I. It does not work like that. So if I set this up, more emails. So 3 times 3 is 9. 3 times negative I is negative 3i. Negative 3i over here. And then this is positive I squared, because negative times a negative is a positive, so you just get I squared. But we know that I squared is actually negative 1. So my like terms are 9 and negative 1. So 9 minus 1 is 8. And then negative 3i and negative 3i is negative 6i. That is the end. Thank you very much. Enjoy your homework. Bye-bye.